Okay, so we are going to be going over the section that you read about and took notes on, measuring motion. We're going to be doing some practice with speed and acceleration calculations and a lab. So it's going to be important that you understand this. And we're also going to be doing, hopefully, our first lab report related to this. So we talk about the word motion a lot, and basically it's just the change in position relative to a reference point. And they talked about things like trees, signs, buildings. We use those as reference points. In fact, we use those as reference points also related to kind of like where things are. So that's very familiar to you, hopefully. Now, what is speed? We talk about speed all the time, and we use it in our everyday lives pretty simply. How fast we're going, right? But scientifically, it's the distance traveled, and we divide that by the time that it takes. So you could calculate your speed from your house to Queen of Peace, and you would do your average speed because you're not going to be going the exact same speed the entire time. So those numbers would change. So we'll talk about that a little bit as well. So this is going to be an important equation for you to understand. So we take the total distance divided by the total time, because if I was calculating my average speed on the way to Queen of Peace, I would have to stop at a couple stoplights and stop signs, and I would have to slow down to turn corners and things like that. So we could figure all of that out if we had some information, if I know how long it took me to get there and the distance that I traveled to school. So velocity is very similar, but we have to address the direction that the object is moving. So for example, if you're going north, east, south, or west, that's helpful for situations where we aren't sure where the object is coming from and where it's traveling. So velocity is very similar, and often in our everyday lives it's used sort of interchangeably with speed, but you have to be careful. So this was a great picture that your book showed you, and it's kind of important to note what's going on in this picture. So you can see there's a boy with a backpack on, and he's moving 1 meter per second east towards the front of the bus. The bus itself is moving 15 meters per second east as well. So when you combine those two velocities, right, they're heading in the same direction, east, the boy and the bus are, and you can figure out what we call the resultant velocity. So we take 15 plus 1, because the boy was moving 1, bus is moving 15, and we get 16 meters per second east. However, what happens if he is moving the opposite direction? So now in this picture, he's moving west 1 meter per second, and the bus is moving 15 meters per second east still. So now, if we are going in opposite directions, pretty simple, we subtract. Now, the problems aren't always going to be that easy, but in this case, we're just kind of explaining how it works. So it can get a little more complicated. So acceleration is another term that you're going to hear often when we talk about speed and velocity. So it's a rate at which the velocity changes over time. So if it accelerates, its speed direction or both change, then you're dealing with a lot of different things. So we often use the word accelerate to say going faster, but accelerate actually could be going slower. So we have what's called deceleration, or in other words, negative acceleration. So it would be a decrease in speed and velocity, but terms that we might use instead of acceleration would be negative acceleration or a decrease. So if we decelerate, we essentially slow down. Acceleration, like I said, is often used to say speed up, but it can be negative or positive. So be careful. That's a really important thing to remember in science, because in our everyday lives we don't talk about that. Positive acceleration would be obviously an increase in speed. So we can figure this average acceleration out. We can take the final velocity minus the starting velocity and then divide that by the time it takes to change the velocity. And we can figure that out too. So there's some math involved here. And the final thing we want to talk about is what we call centripetal acceleration. So this would be acceleration in a circular motion. So for example, race cars on a track or a Ferris wheel would have centripetal or circular acceleration. So that's the final part that we want to talk about today related to measuring motion.